in this parabola, we have the vertex at 4, 2. Again, don't forget, subtraction is part of the formula, and don't forget to square it. I always see students forgetting to square it. Now this one, typically we go over 1 and down 1, but this goes 2. That's where this 2 comes from. And since it's going down or it's flipped, it's negative 2. We're going to restrict the right-hand side of the parabola using x being greater than or equal to 4. Same thing is true here. We have our vertex of negative 5, 1, negative 1, and over 1 up 1, over 1 up, over 2 up 4, that's the basic parabola where the a value is 1. We're going to restrict this side of the parabola, and so we're going to keep all the x values to the right of and including negative 5. In review, to find the inverse equation, replace f of x with y, switch x and y, solve for the new y, replace the new y with the inverse function. I call it the new y so that you won't just replace y with f of x again. It's not the same y. And then if there are any issues with the horizontal line test, we will note restrictions. So I hope you can see that this function is clearly linear. Replace f of x with y, switch x and y, solve for the new y, and then replace that with f inverse of x. It's a line, so all lines go forever left and right, and all lines go forever up and down. Here, I rewrote it so you can see the vertex form. So the vertex is going to be 0, 11. Not that we need that, but I think it's going to help because we can see our upside down parabola going down from the vertex of 0, 11. Replace g of x, catch that, with y. Switch x and y. Get the y squared by itself. To get y by itself, we have to get rid of the square, so we root both sides. Don't forget the plus or minus. And since we want it to be 1 to 1, we'll make it just positive, because we'll take this red portion here as the restricted domain. And so if we look at the range of the original function, it goes from negative infinity to 11, the original function, and we take the domain of the original function, it goes from 0 to 8. Notice, I know, it's asking about the inverse function. Why can't we talk about the original function and switch the domain and the range? This is a line with a negative slope and a y-intercept of 3. How about something like this? Replace, oh, by the way, did you notice, I forgot to mention this, that the new inverse function is not f of x, but g inverse of g of x. We use a g here. Don't make this careless mistake of putting an f there. Same thing with the h of x here. When we're done, we're going to have an inverse h of x. So we replace the function name by y, we switch x and y, we get the y by itself, we subtract 3, and then multiply by -6 to get the y by itself, and we're done. If it's a line with any kind of slope, the domain and range are the same. Same thing here. What I did is I sketched the graph. It's a parabola going up. The vertex is -1, -5. Replace f of x with y. Switch x and y. To get this y by itself, I add 5 to both sides, divide both sides by 7 to get here. To get rid of the squared, I root both sides. Initially, I get plus or minus, but if I take the portion to the right, I only use the positive, and then, you're right, I forgot, I take the y value and replace it with f inverse of x. For E, since they suggest we try writing the vertex form first, that's probably good practice. So we find the x-coordinate of the vertex with -b/2a. Quick reminder, here's b, the opposite is -4. A is 1 times 2 is still 2. I get -2 for the x-coordinate of the vertex. I replace the x values with -2. Square first, don't forget to square first, and then go from left to right, and we get -2. There's our vertex. And like I did earlier, I made a quick sketch. There's our vertex of -2, -2. Since the a value is positive, it goes up. So here's our equation in vertex form. We switch x and y. To get this y by itself, I root both sides. And then because we're talking about the positive end, my plus or minus just becomes addition. Okay? And so again, if I'm looking for the domain of the inverse, can't I take the original graph and take the range, which is from -2 to infinity? And if I'm looking for the range of the inverse function, can't I again take the original function and find the domain, which is -2 to infinity? So here, we could be wrong and right, because if we switch them, we'll never know. Let me go back and make sure you understood this one up here, D, that if I take the original function's range, that goes from -5 to infinity, that's the domain of the inverse. If I take the original function's domain, which goes from -1 to infinity, that's the inverse's range. I can see the original function, I just take the domain and range of the original function and switch them.